Okay, so we're going to talk about exponent laws. Now, the handout that I have given you is what we're going to call a cumulative review. So there is a lot more practice questions that I can give you if you're really struggling with this. However, I didn't want to overwhelm you because I've also given you that practice test booklet, and you have all of your note guides from before as well. So a couple of things that are going to that we're talking about here. A little bit of a review on our exponents. Review for exponents. Okay, so whenever we're given a number that, or when it says rewrite using exponents, rewrite using exponents, this is a form of simplification. Okay, so whenever you're asked to simplify a problem, this might be what you're going to do. So the first example that we have here is just 4 times 4 times 4. And so if we're rewriting that using exponents, we're just going to count up the number of 4s because they're all being multiplied together, and that will be our exponent. So this is equal to 4 to the power of 3. So this part's really simple. If you had 15 times 15 times 15 times 15, this is just 15 to the power of 4. You can also go backwards. So if I say you're going to have 6 to the power of 3 plus 4 to the power of 7, and I want you to rewrite that in expanded form, so we call this expanded form. Then what this would look like is we would have 6 times 6 times 6 plus 4 times 4 times 4. Oh my goodness, I shouldn't have written out the number 7. 4, 5, 6, and 7. Okay, so that's what this would look like here. Does that make sense? Okay, so there's a couple of exponent laws that we need to review here. And what exponent laws are is basically just rules for how we deal with exponents. So if we are given a number where we've got 4, let's just do this simply. 4 squared to the power of 4, and there's brackets here. What we're going to do is multiply these two exponents together. So this is power of a power law. A power law. Okay, so we have 4 to the power of 2. All of that's to the power of 4. So this overall would be 4 to the power of 8. Okay, this is because if I have 4 squared, that's like saying 4 times 4. And then I've got 4 times 4 to the power of 4. So I would write this out 4 times. And I'd be left with 4 times 4, that's my first time, times 4 times 4, that's my second, 4 times 4, third, and fourth. And so the amount of 4s that I have is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's why my power of a power law works. Any questions about that? Okay. Okay, I also have my division rule. Okay, and when I'm dealing with my division rule, that's like whenever I have a fraction. So if I have 10 squared, actually I'm going to make that 10 to the power of 4, divided by 10 squared, what I'm doing is subtracting these two exponents. Okay, so my first one, as long as they have the same base, so they need the same base, then I'm going to subtract my exponents. So this would be 10 to the 4 minus 2. Okay, which would just equal 10 squared in this case. questions? Okay. Our zero rule. Anything to the power of 0 is, does anyone know?
1.
Yes. So 10 to the 0 equals 1. 4 to the power of 0 equals 1. 274 to the power of 0 equals 1. Okay. Negative exponents.
Yes.
Okay, negative exponents we deal with by flipping our fraction. So if I've got 4 negative to the power of negative 2, what that really is telling me is we're using division in a way. So I'm going to have 1 over 4 squared. If, in a more complicated way, I have 4a to the negative 2, that squared is only on my negative a. So I would have 4 over a squared. If there were brackets, that would be different. But because there are no brackets, that negative 2 is only on my a squared. Okay? Did I miss anything? Okay, that's exponents. Let's talk roots. Roots are my inverse of exponents. Okay, so if I'm looking for a root, what I'm trying to do is simplify it so that I have a smaller number inside my radical. So the radical is this. I want the smallest number possible inside the radical or no radical at all. So if I'm going to simplify, let's just look at this first one here. 3 root 3 plus 7 root 3. In this situation, what's happening is my 3 on the outside of my bracket here is being multiplied to my root 3. And my 7 is being multiplied to my root 3. Because these are both multiplying to root 3's, pretend like it's a variable. So if you had 3x plus 7x, we would just add them together. We would have 10x. And so all I'm going to do for this situation is I'm going to have 10 root 3. Does that make sense? Are you following so far? Yeah? Okay. If I want to simplify, so say, because 3 we can't divide into anything, we can't factor anything out. If I want to simplify, let's say, root 27. Okay. What I'm going to do is factor out root 27. So 27 is 3 times 9. And then the 9 is 3 times 3. So inside root 27, I have 3 times 3 times 3. All following so far? So because there's 3 3's inside my radical, and this is a square root, for something to be a square root, you need a pair of numbers. So you need 2 3's or 2 9's or 2 whatever numbers it is. I'm going to take 2 of these 3's. They get to pair up with each other, and they're going to get moved outside of my radical. So what I would be left with is 3 root 3. So that's how we would simplify a radical. If you had the cube root of something, you would need 3. If you had the 4th root, you would need 4. Does that part make sense? Okay. So if I was looking for the cube root, whoops, that's not my pen. The cube root of 27, I would take all 3 3s. So I know that this simplify was 3 times 3 times 3. All 3 of these would get grouped together and move outside the radical. And I would be just left with 3. Okay? I'm trying to figure if there's anything else I need to talk about. Okay, that should be my general review here for this section.